In this video, we're going to be talking about graphing polynomial functions. Our first question is, how do I sketch polynomial functions? So when we have a linear function of the general form f of x equals x, or g of x equals negative x. When we have a quadratic of the form f of x equals x squared, the degree of this function is 2 because the exponent is 2, and it is considered an even function. When our exponents are even, so 2, 4, 6, 8, and other even numbers, it's considered an even polynomial or an even function. Then we have the quadratic g of x with negative x squared, which is just a reflection over the x-axis for all of these. Our cubic has a general shape such as this, where f of x is equal to x cubed. And once again, a reflection over the x-axis gives us g of x, which is negative x cubed. And once again, these are just the general forms for different types of polynomial functions. Our end behavior is asking us to look at when our function's x values approach a positive infinity, over here on the left side or the right side of our graph. What do the y values of the function, and vice versa. So when you have a positive even function, first off, a positive even function would open up, would be above the x-axis, and would open up. Much like our parabola was an even function, any other type of even function will be in the same direction, and since it's positive, it's opening up. Our f of x values, or our y values, approach a positive infinity when our x values, so our f of x approaches a positive infinity when our x values approach a negative infinity. Our f of x values approach a positive infinity again when our x values approach a positive infinity. And these rules apply for all positive even functions. Now for a negative even function, once again, our function would be opening in the same direction, so the end behaviors would be the same, but since it is negative, it would be below our x-axis. And that end behavior states the f of x values go to a negative infinity when x goes to a negative infinity. The x values also approach a positive infinity when our x values approach a positive infinity. Which makes sense. When our x values go negative, the f of x values are also negative. A positive odd function would be a function that begins above the x-axis but ends in below the x-axis. The reason it makes it odd, much like our cubic function, is we have its two directions. And so here, our f of x values approach a positive infinity when our x values approach a negative infinity. F of x values approach a negative infinity when our x values approach a positive infinity. And finally, a negative odd function begins below the x-axis and ends above the x-axis. And once again, our end behavior here, our f of x values go to a positive infinity when x goes to a positive infinity, and our f of x values approach a negative infinity when our x values approach a negative infinity. When we're determining our end behavior, you don't have to memorize these rules. You just need to make sure you can look at the graph and see when our x values decrease, what's happening to our y values. And remember where negative and positive infinities represented on both these axes. So now we're going to talk about the individual zeros or roots of these different functions. When we have a polynomial in factored form, and we have one factor that's of the form x minus a, this is a linear factor, and so it will give us a straight line, and we will also have a single root from it. When we have a factor x minus a squared in our factored form, we'll have a mini parabola and a double root with it. When we have in factored form a factor x minus a cubed, this gives us a mini cubic function, and we are said to have a triple root from it. And so an example of this is if we have the function f of x equals x times quantity x minus 1 squared, we first say the degree of our polynomial is the sum of all the exponents, and so the exponent with our x is considered to be 1, and 1 plus 2 is 3, so we have a 3-degree polynomial with roots with a single root at 0 and a double root at 1. And once again, I established this by using these rules we established up here. Since x minus 1 squared fell into this form, it gives us a double root, meaning we will have a mini parabola touching on the x-axis at 1. And since we have a degree of 3, we know that we'll have a positive odd polynomial when we graph it. So let's look at the sketch of this graph. We have a root at 0, and then a double root at 1, and if it's a positive odd, we'll start in one direction, passing through the point 0, 0, and then we have to change directions in order to hit our one root, but since it's a double root, it's only touching, not crossing, and so it will bounce back and increase. And so our function will look like this. It's important to know these different rules for sketching different polynomial functions because we're not going to accurately graph each type of function. We just want to see the general shape, the degree, and where our roots are in order to sketch them.